Server program in Java remote method invocation. Now we are focusing on server program. A typical server program creates some remote objects, make references to these objects accessible, and wait for clients to invoke methods on these objects. Here this diagram is with about downloading Java RMI stubs with related to dynamic code downloading using Java RMI using the java.rmi.server.codebase property. Using Java RMI, applications can create remote objects that can accept method calls from clients in other VMs. In order for a client to call methods on a remote object, a client must have a way to communicate with the remote object. Rather than having to program the client to speak the remote object's protocol, Java RMI uses special classes called stubs that can be downloaded to the client that are used to communicate with to make method calls on the remote object. The java.rmi.server codebase property value represent one or more URL locations from which these stubs and any classes needed by the stubs can be downloaded. Like applets, the classes needed to execute remote method calls can be downloaded from file :////URLs, but like applets, a file :////URL generally requires that the client and the server reside on the same physical host, unless the file system referred to by the URL is made available using some other protocol such as NFS. Generally, the classes needed to execute remote method calls should be made accessible from a network resource such as an HTTP or FTP server. Here is step 1. The remote objects code base is specified by the remote object server by setting java.rmi.server.codebase property. The Java RMI server registers the remote object bound to a name with the RMI registry. The codebase set on the server VM is annotated to the remote object reference in the Java RMI registry. Number 2, step 2, the Java RMI client requests a reference to a named remote object. The reference, the remote object stub instance, is what the client will use to make remote method calls to the remote object. Step 3, the Java RMI registry returns a reference, a stub instance to the requested class. If the class definition for the stub instance can be found locally in the client's class path, which is always searched before the code base, the client will load the class locally. However, if the definition for the stub is not found in the client's class path, the client will attempt to retrieve the class definition from the remote code base object. Step 4, the client requests the class definition from the code base. The code base the client uses is the URL that was annotated to the stub instance when the stub class was loaded by the registry. Back in step 1, the annotated stub for the exported object was then registered with the RMI registry bound to a name. Step 5, the class definition for the stub and any other classes that it needs is downloaded to the client. Note, step 4 and 5 are the same steps that the registry took to load the remote object class when the remote object was bound to a class name registered with the Java RMI registry. When the registry attempted to load the remote object stub class, if it requested the class definition from the code base associated with the remote object. Step 6, now the client has all the information that it needs to invoke remote methods on the remote object. The stub instance acts as a proxy to the remote object that exists on the server. So unlike applet, which uses code base to execute in its local VM, the Java RMI client uses the remote object's code base to execute code in another potentially remote VM, as shown here. So here, server that exported the remote object, and here the java.rmi.server.codebase equal URL here, and server registers a remote object bound to a name from server that exported the remote objects to RMI registry. And then in step 2, this is RMI client, and RMI client makes a naming lookup call to RMI registry. Then RMI registry returns an instance of the remote object stub to RMI client, Then RMI client request the stub class from the code base. This is the URL location in my host. Then HTTP server returns the remote object stub class to client, and finally the RMI client makes a remote method call to remote object instance here. As an example, we can consider these code segments to implement the server. A remote object is an instance of a class that implement remote interface. Remote interface extend the interface java.rmi.remote and declares a set of remote methods. Each remote method must declare java.rmi.remote exception or a superclass of remote exception in its throws clause, in addition to any application specific exceptions. Here is a interface definition for a remote interface. As an example, it declares one method which returns a string to the caller. Remote method invocation can fail in many additional ways compared to local method invocation, such as network related communication problems and server problems, and remote methods will report such failures by throwing a java.rmi.remote exception. A server class here in this context is the class which has the main method that creates an instance of the remote object implementation, exports the remote object, and then bind that object bind that instance to a name in a Java RMI registry. This the class that contains main method could be implementation class itself or another class entirely. In this example here, the main method for the server is defined in the server class, which also implements the remote interface hello. The server's main method does the following: create and export a remote object and register the remote object with a RMI registry. Implementation of class server implements the remote interface hello, providing an implementation for the remote method say hello. The method say hello does not need to declare that it throws any exception because the method implementation itself does not throw remote exception, nor does it throw any other checked exceptions. Note a class can define methods not specified in the remote interface but those methods can only be invoked within the virtual machine running the service and cannot be invoked remotely. Now we are considering create and export a remote object. The main method in the server needs to create the remote object that provides the service. Additionally, the remote object must be exported to the Java RMI runtime so that it may receive incoming remote calls. This can be done as follows here. The static method unicast remote object dot export object exports the supplied remote object to receive incoming remote method invocation on an anonymous TCP port and returns the stub for the remote object to pass to clients. As a result of the export object call, the runtime may begin to listen on the new server socket or may use the shared server socket to accept incoming remote calls for the remote object. The return stub implements the same set of remote interfaces as the remote objects class and contains hostname and port over which the remote object can be contacted. Note, as of J2SC 5.0 release, stub classes for the remote objects no longer needed to be pre-generated using the RMIC stub compiler unless the remote object need to support clients running in pre 5.0 VMs. If your application needs to support such clients, you will need to generate stub classes for the remote object used in the application and deploy those stub classes for clients to download. Now we are focusing on register the remote object with Java RMI registry. For a caller, client, peer, or applet to be able to invoke a method on a remote object, the caller must first obtain the stub for the remote object. For bootstrapping, Java RMI provides a registry API for applications to bind a name to a remote object stub for clients to look up the remote objects by name in order to obtain their stubs. The RMI registry is a simplified name service that allows the clients to get a stub to a remote object. In general, a registry is used, if at all, only to locate the first remote object a client needs to use. Then typically the first object would be in turn provide application specific support for finding other objects. For example, the reference can be obtained as a parameter to or return a value from another remote object's call. Once a remote object is registered on a server, callers can look up the object by name, obtain a remote object reference, and then invoke remote methods on the object. In this code here, in the server, obtain the stub for the registry on the local host and default registry port, and then uses the registry stub to bind the name hello to the remote object's stub in the registry. The static method local registry dot get registry that takes no arguments returns a stub that implements the remote interface java.rmi.registry and sends the invocation to the registry on server's local host on the default registry port of 1099. The bind method is then invoked on the registry stub in order to bind the remote object stub name hello in the registry. Note the call to locate registry get registry simply returns an appropriate stub for the registry. The call does not check to see if a registry is actually running. If no registry is running on the TCP port 1099 of the local host, when the bind method is called, bind method is invoked, the server will fail with remote exception. Here the method getRegistry returns a reference to the remote object registry for the local host on the default registry port 1099. And here the interface remote. The remote interface serves to identify interfaces whose methods may be invoked from a non-local virtual machine. Any object that is a remote object must directly or indirectly implement this interface. Only those methods specified the remote interface and interface that extend the java.rmi remote are available remotely. Interface remote. The remote interface serves to identify interfaces whose methods may be invoked in non-local virtual machine. Any object that is a remote object must directly or indirectly implement this interface. Only those methods specified in the remote interface, an interface that extend java.rmi.remote are available remotely. As an example 2, we can consider this property java.rmi.server.hostname property. The value of this property represent the hostname string that should be associated with remote stubs for locally created remote objects. In order to allow clients to invoke methods on the remote object, the default value of this property is the IP address of the local host in dotted quad format. As example 3, we can consider this one starting the server in Microsoft Windows, and before starting the server, you need to start the RMI registry. RMI registry is a simple server-side bootstrap naming facility that enables remote clients to obtain a reference to an initial remote object. It can be started with the RMI registry command. Before you execute RMI registry, you must make sure that the shell or window in which you run the RMI registry either has no class path environment variable set or has a class path environment variable that does not include the path to the any classes that you want to download it to clients in your remote objects. To start the registry on the server, execute RMI registry command. This command produces no output and is typically run in the background. For example, this is for the Windows. Use Java W if start is not available. Once the registry is started, you can start the server. You need to make sure that both this Java file and the remote object implementation classes are in your class path. When you start, you have to specify the java.rmi.server.codebase property, where the server's classes are network accessible. In this example, the server-side classes to be made available for downloading are here, and which are available in the compute.jar file in the public _html and / classes directory of user and here. So the server started. So we started on the my host my computer. The same host on which the registry was started. This property, the java.rmi.server.codebase property, specify the location, a codebase URL from which the definition for the classes originating from this server can be downloaded. If the codebase specify a directory hierarchy as opposed to a jar file, you must include the trailing slash at the end of the codebase URL. the java.rmi.server.hostname property specify the hostname or address to put in the stubs for remote objects exported in this Java virtual machine. This value is the hostname or address used by the client when they attempt to communicate remote method invocations. By default, RMI implementation uses the server's IP address as indicated by the java.net.inetaddress.getLocationHost API. However, sometimes this address is not appropriate for all clients and a fully qualified hostname would be more effective. To ensure RMI uses the hostname or IP address for server that is routable from all potential client, set the java.rmi.server.hostname property. The java.security.policy property is used to specify the policy file that contains the permissions you intended to grant. Now we are considering package java.rmi.server provide classes and interfaces for supporting the server side of RMI. One group of classes are used by the static stubs and skeletons. Another group of classes implements RMI transport protocol. Deprecated skeletons and static stubs. Skeletons and statistically generated stubs are deprecated. This provides the APIs in this package that require the use of skeletons or static stubs and the runtime support for them. Support for skeletons and static stubs may be removed in future release of the platform. Skeletons are unnecessary as server-side method dispatching is handled directly by the RMI runtime. Statistically generated stubs are necessary as stubs are generated dynamically using proxy object. See unicast remote object for information about dynamic stub generation. Now this package is in the module java.rmi. Now we are considering the remote server class. This is in the package java.rmi.server, which is in the module java.rmi. The class remote server. The remote server class is the common superclass to server implementations and provides the framework to support a wide range of remote reference semantics. Specifically, the functions needed to create and export remote objects, that is, to make them remotely available, are provided abstractly by remote server and concretely by its subclasses. Now we are considering the RMI Security Manager class. The class RMI Security Manager. The RMI Security Manager implements a policy identical to the policy implemented by Security Manager. RMI application should use the Security Manager class or another appropriate Security Manager implementation instead of this class. RMI's class loader will download the classes from remote locations only if a Security Manager has been set. This is deprecated for removal. This API element is subject to removal in future version. This class is only useful in conjunction with the Security Manager, which is deprecated and subject to removal in future release. Consequently, this class is also deprecated and subject to removal. This is no replacement for Security Manager or this class. This is in the package java.rmi and which is in the module java.rmi. Now we are considering Java RMI class loader class. RMI class loader. RMI class loader comprises statics method to support dynamic class loading with RMI. Included are methods for loading classes from the network locations, one or more URLs, and obtaining the location from which the existing class should be loaded by remote parties. These methods are used by the RMI runtime when marshalling and unmarshalling classes contained in the arguments and return values to remote method calls, and they also may be invoked directly by application in order to mimic RMI's dynamic class loading behavior. This is in the package java.rmi.server and which is in the module java.rmi. Now we are considering the loader handler interface. Interface loader handler deprecated and no replacement. Loader handler is an interface used internally by the RMI runtime in previous implementation versions. It should never be accessed by application code. This is in the package java.rmi.server and which is in the module java.rmi. Now we are considering RMI socket factory class. In RMI socket factories, note that the class below uses socket and server socket from java.net package. RMI socket factory class RMI socket factory. An RMI socket factory instance is used by the RMI runtime in order to obtain the client and server sockets for RMI calls. An application may use set socket factory method to request that RMI runtime use its socket factory instance instead of default implementation. This is in the package java.rmi.server, which is in the module java.rmi. Here the java.rmi.server RMI socket factory abstract class provide an interface for specifying how the transport should obtain sockets. Note that the class below uses socket and server socket from the .NET package. Static method set socket factory is used to set the socket factory from which RMI obtains sockets. The application may invoke this method with its own RMI socket factory instance only once. The application defined implementation of RMI socket factories could, for example, do primarily filtering on the requested connection and throw exceptions, or return its own extension of java.net.socket or java.net.server socket classes, such as ones that provide a secure communication channel. Note that the RMI socket factory may only be set if the current security manager allows setting socket factories. If setting socket factory is disallowed, the security exception will be thrown. The static method get socket factory returns the socket factory used by RMI. The method returns null if the socket factory is not set. The transport layer invokes create socket and create server socket methods on the RMI socket factory returned by the get socket factory method when the transport needs to create sockets. For example, RMI socket factory dot get socket factory method dot create socket factory my host my port. The method create socket should create a client socket connected to the specific host and port. The method create server socket should create a server socket on the specified port. The default transports implementation of RMI socket factory provides provides for transparent RMI through firewalls using HTTP as follows. The create socket the factory automatically attempts to HTTP connections to hosts that cannot be connected with direct socket. On create server socket, the factory returns a server socket that automatically detects if the newly accepted connection is an HTTP post request, so that it returns the socket that will transparently export only by the only by the body of the requested transport and format its output as HTTP response. The method set failure handler sets the failure handler to be called by the RMI runtime if the creation of a server socket fails. The failure handler returns the boolean to indicate if retry should occur. The default failure handler returns false, meaning that by default recreation of sockets is not attempted by the runtime. The method get failure handler returns the current handler for the socket socket creation failure or null if the failure handler is not set. You can use RMI socket factory class to create a server socket that bound to a specific address, restricting the origin of requests. For example, the following code implements a socket factory that binds the server socket to IP4 loopback address, IP version 4 loopback address. This restricts RMI to processing requests only from localhost. Set the java.rmi.server.hostname system property to 127.0.0.1 to ensure that generated stubs connect to the right network interface. Just call the default client socket factory. Now we are considering the RMI failure handler interface. The java.rmi.server.RMI failure handler interface provides a method for specifying how the RMI runtime should respond when the server socket creates fails except during object export. The interface RMI failure handler. An RMI failure handler can be registered via the RMI socket factory.set failure handler call. The failure method of the handler is invoked when the RMI runtime is unable to create the server socket to listen to incoming calls. The failure methods returns the boolean indicating whether the runtime should attempt to recreate the server socket. This is in the package java.rmi.server and which is in the module java.rmi. The java.rmi.server.rmi failure handler interface provides a method for specifying how the RMI runtime should respond when the server socket creation fails except during the object export. The failure method is invoked with the exception that prevented the RMI runtime from creating java.net server socket. The method returns true if the runtime should attempt to retry and false otherwise. Before this method can be invoked, a failure handler needs to be registered via the socket factory.set handler call. If the failure handler is not set, the RMI runtime attempts to recreate the server socket after waiting for a long period of time. Note that the RMI failure handler is not called when server socket creation fails upon initial export of the object. the RMI failure handler will be called when there is an attempt to create server socket after a failed accept on server socket. Now we are considering the logstream class logstream deprecated, no replacement. Logstream provides a mechanism for logging errors that are of possible interest to those monitoring system. This is in the package java.rmi.server, which is in the module java.rmi. Here we are considering the stub and skeleton compiler. For example, the running RMIC on class file name hello impl as shown here. In Windows RMIC, the Java RMI compiler, the RMIC compiler generates stub and skeleton class files, JRMP protocol, and stub and TIE class files, IIOP protocol for remote objects. These class files are generated from compiled Java programming class language classes that are remote object implementation classes. The remote implementation class is a class that implements the interface java.rmi.remote. The class names in the RMIC command must be of classes that have been compiled successfully with the Java C command and must be fully package qualified. For example, running RMIC on the class file name hello impl as shown here. In Unix RMIC, the deprecation not support for static generation of Java remote method protocol, JRMP stubs and skeleton have been deprecated. Once recommends that you use the dynamically generated JRMP stubs instead, eliminating the need to use this tool for JRMP based applications. The RMIC compiler generates stubs and skeleton classes for using files using the Java remote method protocol, JRMP, and stub and TIE class files, IIOP protocol for remote objects. These class files are generated from compiled Java programming language classes that are remote object implementation classes. The remote implementation class is a class that implements the remote interface java.rmi.remote. The class names in the RMIC command must be for classes that were compiled successfully in the Java C command and must be fully qualified, must be fully package qualified. For example, running the RMIC command on the class file name hello impl as shown here creates the hello impl underscore stub.class file in the hello subdirectory named for the classes package. Now we are considering properties that are useful to set on virtual machines VMs that export remote objects in java.rmi properties. The java.rmi.server.codebase property. This property specifies the location from which classes that are published by this VM. For example, stub classes, custom classes that implement the declared return type of a remote method call or interfaces used by a proxy or stub class may be downloaded. The value of this property is a string in URL format or a space generated list of URLs that will be a code base annotation for all classes loaded from the class path of and subsequently marshaled by this VM. Note this property must be set correctly in order to dynamically download classes and interfaces using Java remote method invocation, Java RMI. If this property is not set correctly, you will likely encounter exceptions when attempting to run your server or client. For more information on this property, see dynamic code downloading using Java RMI in the documentation using the java.rmi.server.codebase property. Now we are considering properties that are useful to set on VMs that make remote method calls. Java.rmi.server.codebase. This property specifies the location from which the classes that are published by this VM, for example, custom classes that implements the interface that is the declared parameter of a remote method call may be downloaded. The value of this property is a space separated list of URLs that will be the code base annotation for all classes loaded from the class path of and subsequently marshaled by this VM. Note this property must be set correctly in order to dynamically download classes and interfaces using Java remote method invocation, Java RMI. If this property is not set correctly, you will likely encounter exceptions when attempting to run your server or client. For more information on this property, see dynamic code downloading using Java RMI in the documentation using the java.rmi.server.codebase property. Now we are considering properties that are useful to set on virtual machines VMs that export remote objects in java.rmi properties. the class path of and subsequently marshaled by this VM. Note the classes that exist in both server code base and the client class path will be loaded from the client's class path rather than from the server's code based as intended. Now we are considering properties that can be set on our RMID in Java in sun.rmi properties. Sun.rmi.server.activation.debug exec. If this value is true, the activation system will print out debugging information to the command line that is used for spawning activation groups. By default, the value is false, so debugging information is not printed. Now we are considering properties that are useful to set on VMs that export remote objects. Java.rmi.server.exception trace. This property controls the output of a server-side stack traces from exception and errors that are thrown by dispatched incoming remote calls. If this value is true, the exception stack traces will be printed. By default, false. Exception and error stack traces are not printed. Now we are considering Java RMI implementation logging. System property name java.rmi.server.log calls. The logger name sun.rmi.server.call. Information logged, server-side remote calls and exceptions. As an exception example, we can consider server exception. A server exception is thrown as a result of a remote method invocation when remote exception is thrown while processing the invocation on the server, either while unmarshalling the argument or executing remote method itself. A server exception instance contains the original remote exceptions that occurred as its cause. The class server exception is in package java.rmi. As an error example, we can consider server error. The class server error. A server error is thrown as a result of a remote method invocation when an error is thrown while processing the invocation on the server, either while unmarshalling the argument, executing the remote method itself, or marshalling the return value. A server error instance contains the original error that occur as its cause. This class server error is in package java.rmi.